In this video, we're going to add a test to our recast.yaml file to test the second stat analysis step of our workflow. So to do that, I'm first going to just copy the event selection test, because again, there's going to be a fair bit of repetition, and I'll just call it stat analysis and update the step that's being tested. Now, the other thing that we're going to have to update is the parameters that get read in and out of this stat analysis step. So we're no longer reading in a signal file from EOS. Instead, it's going to be read in from the event selection that produced the skimmed version of the signal file. But in terms of files that get read in from EOS, we're going to read in the background file. And you can see in our recast inputs directory on EOS, there's a background.root file, a data.root, and a signal.root. So we'll be reading in the background.root for this one. And then we also want to read in the data file. And then we're going to have to specify the output directory. So remember in our specs.yaml, steps.yaml, we were outputting this, the results of the stat analysis into this output dir. So we'll have to specify where that gets produced. And let's put it in a directory called recast results in our work dir. And then the last thing that we need is to read in the skimmed signal file that got produced by our event selection. So that's going to need to be read in from this previous step. And remember, it was called skim signal in the steps.yaml file. So it's not actually clear at this point how we're going to read in the output from this previous event selection, because remember, when we ran the test, it just produced a directory called recast test dash a bunch of numbers and letters, and that's that a new directory gets produced every time the test gets run. So it's not clear how to output anything contained in that directory into as input to the next step. So what we do instead is we output and input the files to and from a common directory. And the way that's done, if we go down to testing and using test data in the recast docs for workflow authoring and defining steps, there's this field that you can specify called data. And what this is telling recast is to write any inputs or outputs of this step to test data, and this read dir 0 variable gets set to the path to this test data directory on your machine. So let's make that update first by adding this data field. And then we're actually going to have to update the first step so that rather than writing the signal skim.root into the work dir, it's instead writing it into this read dir 0. And now we can do the exact same thing and read in the skimmed signal from this read dir 0 / signal skim.root. And then similarly, we can update the output dir to use read dir 0 so that the output of the workflow is also getting written out to this common test data directory. So let's give this a try. The first thing that we're going to need to do is rerun the first event selection step so that we're outputting the results of that step into this common test data directory. So let's see if that's in my history. Okay, it's not, but I can update that. It's called again. Okay, so it looks like that ran okay. And let's check that this test data directory got produced, and good, it seems to have been produced. And the skimmed signal T tree seems to have been written out to it. So that's all good. And now we can try testing the second stat analysis test, or step rather. Okay, that seems to have succeeded, and let's check what got produced. Good. All right, so it produced this recast results directory, and it seems to have the contents we're expecting. So let's take a look at them. Okay, so that has some number, which is presumably the p-value associated with the chi-squared test. And then I'm not actually on my local machine, so I'll have to copy the histos.png onto my local machine to take a look at that. Okay, so that's what it looks like. And you can see, looking back at the README, that this is a little bit different from the histogram that was shown as an example in the README. And so yeah, you can see that the signal is a lot smaller and a lot more consistent. So signals plus background is a lot more consistent with the data. So we're getting a much lower chi-squared value. And the reason for that is just that we're only running over 100 events in the input signal T tree. So this plot got produced for running over all of the events in the input signal T tree. So that's why there's more signal content. So yeah, this is looking as I would expect. So it's a reasonable test to make sure that those steps are doing what we're expecting. Okay, so now that we've got both of our steps encoded and we've validated them with unit tests in our recast.yaml steering file, we can now write the workflow .yaml spec file to encode how the two steps fit together to make the full recast workflow that could just be run with one command. So that's going to be what we do in the next video.